This is a video to help my students catch up with the mole concept. We're going to start with some basic ideas here. For instance, let's look at a dozen. A dozen is a quantity that you're very familiar with. Let's get started here. Let's say you're going to a bakery and you want to know how many cookies are 1.5 dozen cookies. Well, we don't need to actually visit a bakery in order to do this. Okay, we can just look at what a dozen means already. So we can say 1.5 dozen on this side, and we want to know on this side how many cookies are there. So we're going to use a bridge method, and it's going to be a one-step question here because the word dozen is in our statement here, our question, and I know that there are 12 cookies per 1 dozen, so I multiply it by that ratio, and 1.5 times 12 gives me 18 cookies. Now, of course, we're still at the bakery, and we notice that they have pretzels. And now the question is, what's the cost, okay, for 2 dozen pretzels? Well, I'm going to start on the left side here, again, with what's given, 2.5 dozen. Because the word dozen is in the question, I know that's only a one-step question, equals. I want to know how many dollars that equals. Well, of course, I have to look at the prices, okay, in the bakery. So let's go to the bakery. Okay, here it is. And the pretzels, it says it's $6.40 per dozen. So once I visit the bakery, I know it's $6.40 per dozen. So I write it again as a ratio. $6.40 per 1 dozen. That comes out to be $16. Because I'm just going to multiply 2.5 times 6.40. Now the next question. How many buns can you get, okay, with $10? Well, we don't know the direct comparison there. So I will start with dollars on this side. I've got $10. And over here, I want to know how many buns, okay, that is going to equal. This is going to be a two-step question because I don't see the word dozen in my question here. So I'm going to start, there's a definite pattern here. I'm going to put 1 dozen on top here. Okay, there's my first step, and there's going to be something on the bottom there. And then I'm going to have 1 dozen on the bottom over here. And this is always the pattern with the two-step. The 1 dozen will be here on the top, and then 1 dozen will be here on the bottom. Well, I do know that there are 12 buns in 1 dozen, so I can fill that in really quickly there. But what about this? Well, I have to go to the bakery again to figure out the cost for 1 dozen. So let's go back to the bakery. And this is 4 buns this time. And I click on this. It says it's $3.75 per dozen. So once I visit the bakery, I now know the cost. So then I'll put the $3.75 here. Notice how I have dollars here. Dollars must be on the bottom here. I've got buns on top here, therefore I must have buns on top there. So I'm going to take 10 divided by 3.75 and multiply that by 12. And the answer comes out to be 32 buns. So we use the dozen as an analogy because it helps us understand the problem solving for the mole. The mole happens to be the same kind of pattern, except 12 is too small of a quantity for something like atoms. So we use Avogadro's number. Avogadro's number is a much larger number, 6.02 times 10 to the 23rd. We can enter this in our calculator as 6.02 E23. Why such a large number? Well, think of the dozen, 12. If I asked you to look at 12 atoms of carbon, that would not be possible. 12 is too small of a number. You wouldn't be able to see 2 atoms. They're too tiny. So you need a very, very, very large number. Avogadro discovered that this number converts all of the atomic masses in the periodic table to grams. Let's see how it works. So here's our periodic table. Okay, let's take a look at lithium. Lithium has a mass of about 6.9. So that means 1 mole of lithium has 6.9 grams in it. This is like the bakery cost. Like this is how much does it cost? How many atoms would that be? Well, it would be 6.02 times 10 to the 23rd. Let's take a look at carbon. Carbon has a cost of about 12.01. In other words, that's its grams. But how many atoms of carbon is that? That would be 6.02 times 10 to the 23rd. Notice how the 6.02 times 10 to the 23rd stays the same for all atoms, but their cost is different. Just like the bakery, a dozen was 12, but the cost per dozen was different. What's really the cost on the periodic table? It's their atomic masses. Look at sulfur, 32.06 grams of sulfur. That will equal 6.02 times 10 to the 23rd atoms of sulfur. Let's practice one question here. How many atoms of sodium are in 1 mole of sodium? Well, I know that answer. It's 6.02 times 10 to the 23rd. And I'm just going to write E23. How many grams are in 1 mole of sodium? Well, I must go to the bakery. This one I don't need the bakery, kind of like I always know a dozen is 12. I know that 1 mole is always this number. But if I ask for grams, I must go to the bakery. What's our bakery in chemistry? The periodic table. So here I go. I touch on that. Well, I look at that, and it's 22.9898 if I round that. So if I go back to answer my question here, it's 22.9898 grams. I could have kept more digits, but I think that's plenty for that. And that's how we deal with the mole concept. In the next video, we'll see how we apply this to quantities that aren't exactly equal to 1 mole.